Hello friends, today let's look at the algorithm of serializing and deserializing a binary tree. This algorithm runs in order of n time. So the problem statement is, we are given a binary tree and we are supposed to serialize it first and then deserialize it. In serialization, we store the given tree in a file or in an array, and in deserialization, the input is a file or an array and we need to recover the original binary tree. So in serialization, our input is a binary tree and we need to store that binary tree in a file or in an array, and in deserialization, our input is a file or an array and we need to recover the original binary tree from the given input. In this video, we are going to use the pre-order traversal for serialization process, and the deserialization would be to obtain or to recover the original binary tree given the serialized form which is obtained using pre-order traversal array. So let's look at the serialization using pre-order traversal first. A pre-order traversal array is created by visiting the tree in root node, then left subtree and then right subtree style in recursive manner. So we first visit root node, then we visit nodes in the left subtree, and then we visit nodes in the right subtree, right? So this is root node, left subtree and right subtree. This is done in recursive manner. One more thing that we are going to do while serializing the given binary tree is that we are going to write a special marker of -1 to indicate that we have visited a null node. The code that implements this serialization process is this particular code. Here we are doing a pre-order traversal here, right? We are first visiting the root node and writing its value to the array. Then we are visiting nodes in the left subtree for root node, and then here we are visiting the nodes in the right subtree for the root node. During this pre-order traversal, if we see that the current node or root that we are visiting is null, what we are doing is we are adding -1, which is a special marker to indicate the null node. Okay, let's try to serialize this particular binary tree now. So we are adding the node values to the output array using pre-order traversal. First we visit root node, which is node 7, and add its value to the serialized form. So 7 would be added. Now we go to the left subtree of the root node. The left subtree starts from node 2, right? So we visit root node first. Then we go to the left subtree of node 2, which starts from node 1. So we visit node 1, right? Now we go to the left subtree of current node, which is node 1. The left subtree of node 1 is null. Note that whenever we encounter a null node, we write -1 to the output serialized form. So we write -1 here, right? So this -1 indicates this particular null node. Now we are done exploring the left subtree for node 1. So we go to the right subtree of node 1. Note that the right subtree is also null. Therefore, we write -1 in the output array. Now we are done exploring the left subtree of node 2, right? So we go to the right subtree of node 2. In the right subtree of node 2, only the null node is present, right? So we again write -1 to indicate that. So this latest -1 indicates the right subtree for node 2, which is null. Now at this point, we are done exploring the left subtree of node 7, right? So we go into the right subtree of node 7. The right subtree of node 7 starts from node 5. We visit the root node first, so 5 will be returned to the output. Then we go to the left subtree of node 5, which starts from node 3. So node 3 would be visited. Then we visit the left subtree of node 3, which is null. So we again write -1 in the output. So corresponding to this null subtree, we write -1 to the output. Then we go to the right subtree of 3, which is again null. So we again write -1 in the output. Now at this point, we are done exploring the left subtree of node 5. So now we go to the right subtree of node 5, which starts from node 8. So we again write root node's value, which is 8, to the output. Then we go to the left subtree of node 8, which is null. So we write -1 in the output. Similarly, for the right subtree of node 8, which is again null, we write -1 to the output sequence. Now at this point, we are done exploring all the nodes of the given binary tree, and the output array that we have generated is the serialized form of this binary tree. So overall, the serialized form of this binary tree is this particular array, right? First we visit the root node, then we visit the nodes in the left subtree and then in the right subtree, which is done in recursive manner. We are writing a special marker of -1 to indicate null node. Okay, so this completes the serialization process. The serialization is relatively easy. Let's see how we can recover the original binary tree when we are given this particular array or the serialized form of the binary tree as input. So the input in case of deserialization is going to be a file or an array which represents a binary tree. By looking at this particular input array, before even starting the deserialization, what we know is this array basically represents the binary tree, and this array is obtained by using the pre-ordered traversal, right? We also know that the -1 in the array indicates the presence of null node in the original binary tree, right? So using these ideas, let's now try to deserialize the given array. So for the deserialize subroutine, the input is this particular array, which is basically the serialized form of the original binary tree, right? We start looking at the elements of the input array starting from index 0, right? So this index we are going to use for looking at the input array, which is initialized to 0, right? Now because this input array is obtained by using pre-ordered traversal, we first construct the root node, right? So we construct the root node using the element at the current index. Index is initialized to 0. So root node would be obtained by using, let's say, new node out of the value which is present at the current index, array of index, right? So once we construct the root node, we first increment the index by 1, right? Because we need to start looking at the elements of the input array starting from the next index. And then we need to construct the left subtree. We'll construct this in recursive manner. So I'm making a recursive call to this particular subroutine, deserialize, with input as array, right? Note that whenever we are constructing the root node, we are incrementing the index by 1. Okay, so now at this step, the root.left basically points to the left subtree for the current root node, and then we construct the right subtree for the root node, right? So the right subtree would be made by making a recursive call, right? So input would be array. So after the right subtree is constructed for the current root node, this particular recursive procedure, that is deserialize subroutine, needs to return the reference to the root node, right? So the final statement would be return root. We are returning the reference to the root node that we just constructed, right? So for this particular recursive procedure, which returns reference to the root node, there must be the base case. The base case for this recursive procedure is that whenever we are done looking at all the elements of the input array, that is, whenever value of this index is greater than or equal to the array.length. So this indicates that we are done looking at all the input elements, or whenever we see a -1. So whenever we see a -1 at current index, right, what we do is we simply return null, right? -1 indicates presence of null node. So overall, the implementation for the deserialization looks like this particular procedure, right? This particular if block is the base case, where if we are done looking at all the elements, or if we are looking at element which has value of -1, we simply return null. Note that in the base case as well, we need to increment the index by 1 because we need to look at the elements starting from the next index, right? Okay, so if this particular base case is not true, then what we do is we first construct the root node and then we construct left subtree, which is followed by construction of right subtree, and finally we return the reference to the root node, right? Now what we'll do is we'll run this deserialize procedure for this particular input and try to understand as to how this recursive algorithm is working. For ease of explanation, I'll call this step as step number 1, then this as step number 2. In step number 2, we are creating a root node and then we are incrementing the index by 1. Then I'll call this particular statement as step number 3, where we are creating the left subtree. Then this particular statement as step number 4, and finally the return statement as step number 5. To begin with, this index is initialized to 0. This index basically signifies as to which element of the given input array we are currently looking at. We start looking at input array starting from very first element, which is located at index 0. So we start looking at the input starting from element 7, right? Now in the very first call to the deserialize procedure, value of index, which I am denoting by I, would be equal to 0, right? The first step, which is the base case, will have no effect in this call because the current element we are looking at is 7, which is not -1, and we are also not done looking at all the elements. Therefore, the base case will have no effect. In the second step, what we are doing is we are creating the root node out of current element. Current element is 7, so we create a root node out of element 7 and we increment index I by 1. So I would be incremented to 1, right? Now in the third step, what we are doing is we are making a recursive call to create the left subtree of the current root node, right? Current root node is node 7. In third step, we are making a recursive call to create the left subtree for current root node. So when we made a recursive call, a new call sequence would be started with value of index equal to 1, right? In this call sequence, the first step, which is the base case, will have no effect. In the second step, what we are doing is we are creating a root node out of the element which is placed at current index. Note that value of I is 1, so element 2 is placed at index 1, right? Therefore, in second step, we create a root node out of element 2 and then we increment index I by 1, so I would be incremented to 2. Now in the third step, we are again making a recursive call to create the left subtree for the current root node. Current root node is node 2 and we are making a recursive call to create the left subtree. Now when we are making a recursive call in the third step, a new call sequence would be started. In this call sequence, value of index or I is equal to 2. Then in the first step, which is the base case, we first check if index is equal to array.size. Index is 2, which is not equal to array.size. Then we check if element at current index is equal to -1. Current index is 2, so we are looking at element 1, which is not -1. Therefore, the base case will have no effect. In the second step, what we are doing is, we are creating current root node out of the current element. Current element we are looking at is 1, right? So current root node would be constructed with value as 1. Now I would be incremented by 1, so value of I becomes 3. In the third step, we make a recursive call to create the left subtree of the current root node, right? So after the recursive call is made in step number 3, a new call sequence would be started where value of I is equal to 3, right? So we are looking at the element which is placed at index 3. The element that is placed at index 3 is this particular -1, right? 0, 1, 2 and 3. So we are looking at element which has value of -1. Now in the first step, which is the base case, we are checking if we are done looking at all elements, which is not true, and we are also checking if the value of the current element that we are looking at is -1. Note that we are looking at the element which is -1. Therefore, the base case now comes into play. In this step, what we are doing is, we are first incrementing value of index by 1. So I would be incremented to 4. Then we are returning null to the calling function. So in the base case only, we return null here because that's where we made a recursive call. Note that in step number 3, when we made a recursive call, whatever is the result returned by that recursive call would be the left subtree for node 1, right? Because we are assigning the result of the recursive call to the root.left. Root.left is equal to deserialize array. Now in this case, that particular call sequence has returned null, right? So 1.left would be null. Note that at this point of time, value of index I is incremented to 4. Now we resume the call sequence here where the current root node created is 1. We have already completed 3 steps in here. So we resume execution from step number 4. I'll erase the completed call sequence for more space. So we are resuming the call sequence where the current root node is node 1. 3 steps are completed and we go to 4th step where what we are doing is, we are again making a recursive call to create the right subtree for the current root node. So current root node is node 1. We are making a recursive call to create the right subtree for node 1. So to begin this particular recursive call sequence, value of index I is already 4, right? Value of index I is 4. So basically we are looking at the element which is placed at index 4. Element at index 4 is this particular -1, right? So 0, 1, 2, 3, 4. Then the first step, which is the base case, comes into play because element at current index is -1. Now in the first step, what we do is, we increment index I by 1. So I would be incremented to 5. Then we return null to the calling function. So we return null at this point, right? Now note that whatever is the result that is returned by this particular call sequence, that would be made the right subtree for the current root node in this particular call sequence. From step number 4, what we did was root.right equal to deserialize array. That deserialize array is basically returning null here, right? So in step number 4, we are getting the return result as null, which would be the right subtree for the current root node. The right subtree for node 1 therefore would be null. I'll again erase the completed call sequence for more space. Now the fourth step is also completed for this particular call sequence. At the end of fourth step, value of I is incremented to 5. Note that in the last call sequence, we looked at index I is equal to 4 and then we incremented I by 1. So value of index I is currently 5. Now we resume the execution for this particular call sequence. So we go to step number 5. 4 steps are already executed and the current tree that is constructed in this particular call sequence is this particular tree. Now in step number 5, what we are doing is we are simply returning the root node for the current tree that is constructed in this particular call sequence. So node 1's reference would be returned here, right? Note that in step number 3 for this particular call sequence, whatever is the result that would be returned by the recursive call would be made as the left subtree for the root node that is created in this particular call sequence. The root node that is created in this call sequence is node 2. So node 1's reference would be made as the left subtree for node 2. So after the execution of step number 5, this particular call sequence is complete, which has basically returned the reference to node 1 here, right? I'll erase the completed call sequence now. Okay, now we resume this particular call sequence. 3 steps are completed and the current tree that is built is this particular tree. The root node is node 2 with its left child as node 1, right? Okay, now before starting the fourth step, note that value of index I is 5, right? In the fourth step, what we are doing is we are making a recursive call to create the right subtree for the current root node. We are making a recursive call. So in this call sequence, value of index I is 5. So we are basically looking at the element which is placed at index 5. Note that element at index 5 is this particular -1, 0, 1, 2, 3, 4, 5. Now because the current element that we are looking at is -1, the first step, which is the base case, comes into play. What we do is we first increment I to 6 and then we return null here, right? Because from step number 4 we have made this particular recursive call which returns null, right? So the right subtree for node 2 would be null because in the fourth step we have made a recursive call to construct the right subtree for the current root node. Value of I at this point is 6, right? I'll erase the completed call sequence now. Now in step number 5, what we do is we simply return the reference to current root node. The current root node is node 2 and reference of this node 2 would be returned here because we made this particular recursive call from step number 3, right? So whatever is the result that is returned would be made as the left subtree for the current root node. In this particular call sequence, current root node is node 7. Okay, so we are back into the call sequence where the current root node is node 7. 3 steps are completely executed now and value of I at this point is 6. Now we go to the fourth step to construct the right subtree of node 7. Note that in step number 4, we are constructing the right subtree for the current root node. So in step number 4, a recursive call is made. So very similar to step number 3, where we constructed the left subtree, in step number 4, right subtree would be constructed and the complete tree that would be constructed after step number 4 would be this particular tree. So in step number 4, a complete tree is constructed and in final step, which is step number 5, the reference to root node would be returned to the calling function. So this completes the explanation of this algorithm. I hope that the intuition behind this algorithm is clear now. For similar questions, you can check out our website www.ideserve.co.in. Thank you and cheers.